So in this session we're going to be looking at shapes of molecules. So by the end of the session we should be able to work out the numbers of pairs of electrons around the central atom, deduce the shape of molecules, bond angles and names of the shapes, and explain why a shape has a particular bond angle. So to start, the basic theory is VSEPR, or valence shell electron pair repulsion theory, and that states that electron pairs will repel as far as possible. There will be lone pairs of electrons and they repel more than bonding pairs of electrons, and we're interested in how many pairs of electrons, or we might call it regions of electron density, around the central atom. Okay, so we're going to look at the basic shapes first without thinking about lone pairs for the time being, and there are 5 basic shapes we're going to look at. The first is if there are 2 bonding pairs of electron around the central atom. This has a linear shape and it's got a bond angle, so the bond angle is between the bonds around the central atom, and that is 180 degrees. If there's 3 bonding pairs of electrons, it's called trigonal planar. Again, it's planar because it's flat, so it just takes up the plane of the paper. And the bond angle, which is the bond angle here, is 120 degrees. If there are 4 bonding pairs of electrons, the shape is tetrahedral. The bond angle is 109.5 degrees, or 109 degrees and 28 minutes if you want to be precise, and that is between here, 109.5 degrees. Now this takes a 3D shape, so we can see we've got these dashed and this wedge. The wedge is suggesting that it's coming out of the plane of paper towards you, and the dashed line suggests it's going back behind the plane of paper. So if they're straight lines, just normal bonds, that suggests they're in the plane of paper. Okay, so it's kind of like you've got a Q and an A and a Q here. They're just generic atoms, by the way. And then you've got a Q coming out in front of the paper like this, and this Q here going behind the paper. Okay. That is if you've got 4 bonding pairs, 5 bonding pairs. These form a shape that we call trigonal bipyramidal. Bipyramidal because it's basically like 2 pyramids. So we've got a pyramid at the bottom, sort of here, and a pyramid at the top here. The bond angles are 90 and 120. So the 90 degree is here, and the 120 is here. So again, if we think about this, so the 3 Qs here, they basically form a flat shape, just like the trigonal planar molecule we looked at earlier. So that is, if you imagine a horizontal piece of paper across that way, you've got that going backwards and this coming forwards. This one is another 2 bonds. These are sort of vertical, so the way I sometimes show this is I'll take a piece of paper and I'll stick a pencil through it or something. The pencil going up through the paper is essentially these 2 atoms up here, and then you can draw the Q, Q and Q on a flat piece of paper horizontal. So this is essentially the trigonal planar molecule, but with 2 atoms sticking up and above, which forms 2 pyramids, like 2 inverted pyramids on top of each other. And then we've got 6, which is octahedral. The bond angle certainly isn't 180, it's 90 degrees. Whoops, I apologise for that. So all of these bond angles are 90 degrees, and it's basically, these are 4 bonds, in these 2 going back in the plane of paper, these 2 coming in front, and then these 2 coming up and above. Okie dokie. So how do we work out how many pairs of electrons there are around the central atom? So this is sort of the key bit that we're going to be looking at today. So you first of all need to work out the number of outer shell electrons. That's easy. You just look at the periodic table, it's the group number and it's the central atom. You then add to this the number of atoms that are bonded to the central atom. Then you're going to subtract if there's an overall positive charge and add if there's an overall negative charge, and then finally you'll divide by 2, and that will tell us how many pairs of electrons, lone pairs and bond pairs, there are around the central atom. It's best looked at through an example. So the first example we're going to do is we're going to look at methane. So methane is carbon with 4 hydrogens. The central atom is carbon, so we need to know how many electrons this has. So we're going to go to our trusty friend, the periodic table. So we find carbon in the periodic table, there it is, and it's in group 4, so we know it's got 4 electrons in the outer shell. So we fill in this table. So the number of outer electrons is 4 because carbon's in group 4. There are 4 bonds because it's CH4. The charge, there's no overall charge, so it's 0, which gives us a total of 8 electrons around the central atom. We need to divide this by 2, which gives us 4. As I say, we're not looking at lone pairs for the time being, so we can see 4 pairs of electrons are all bonding pairs, so therefore it's going to be based on the tetrahedral shape, which looks like this. So as I say, you've got those 2 in the plane of paper, that going behind, this coming in front, with a bond angle of 109.5 degrees, and the name of that shape is tetrahedral, or just tetrahedral. Example 2, sulfur hexafluoride. First job, find out how many electrons the sulfur has in its outer shell. Here's my friend, the periodic table. There's sulfur, there it is, just sitting relaxing in group 6 with the other group 6 elements. So we know it's got 6 electrons in its outer shell. Sulfur is bonded to 6 fluorines, so therefore there are 6 bonded atoms, and the charge is still 0. So the total 6 plus 6 plus 0 is 12. We need to divide that by 2, which gives us 6. So then we go back to what we've remembered. We looked at that table. It's based on 6, so it is going to be octahedral with 2 fluorines here, 2 fluorines going backwards there, 2 fluorines coming forwards here, and the bond angle is 90 degrees, not 180. More complicated shapes. So as soon as we introduce lone pairs, it starts to get a little bit more complicated. But as I say, the basic shapes is what they're all based on. So if there are 3 pairs of electrons, then we said it's trigonal planar, but that's if they're all bonding pairs. But if you've got a lone pair, lone pairs of electrons still influence the shape, but you don't see them, if you will. So if you've got 3 pairs of electrons, 2 of which are bonding, 1 of which is a lone pair or non-bonding, the shape will be this. We call it bent. The bond angle is reduced by these lone pairs, so it's reduced by about 2 degrees, so it's reduced to 118 degrees. Okay, you just need to memorize this information. If there's 4 pairs of electrons around the central atom, if there's no bonding pairs, it's tetrahedral 109.5. That's not what this diagram is. If you've got 3 bonding pairs of electrons and 1 lone pair, it forms something called trigonal pyramidal. The bond angle's reduced to about 107 degrees. So essentially, one of these, and it doesn't matter which one really you get rid of, but one of these disappears from the tetrahedral structure. And then here is what happens if you've got 2 and 2, so 2 bonding, 2 lone pairs. It becomes bent. The bond angle reduces again by about another 2.5 degrees. So you've got your 2 atoms here and your 2 lone pairs of electrons there. So let's have a look at an example that uses this. So ammonia. Go to our trusty friend, the periodic table, to find nitrogen. Nitrogen is there. It's in group 5. So there are therefore 5 outer shell electrons for nitrogen. NH3, so there are 3 hydrogens. There is no charge, and the total for that is 8. 5 plus 3 is 8, divided by 2, which gives us the number of pairs of electrons. Now if you see, I've written a big B and a big P here, okay, because this is the number of bonding pairs of electrons, and this is the total number of pairs. So to work out how many lone pairs, we just need to do this, take away this. So 4 take away 3 gives us 1. So this is important because this tells us what the shape is based on, and this tells us what the shape is actually going to be. So the shape is based on the tetrahedral, but with one of the atoms missing. So nitrogen is the central atom. We've got hydrogen. We're going to draw 3 hydrogens. Doesn't matter which 3 you draw. And then we need a lone pair of electrons here. Okay, so this is the shape. We said earlier that this is called trigonal pyramidal, and the bond angle is 107 degrees. It's reduced by about 2.5 degrees from the tetrahedral shape. Okie dokie. Let's have a look at another example, but this time with a charge. So this is thallium bromide. So we find thallium in the periodic table. Here it is. It's in group 3. So there are 3 electrons there. There are 3 bonds, TLBr3, and the charge is 2-. So if it's 2-, that means there are an extra 2 electrons. So the charge is 2-, we need to add 2 here. So 3 plus 3 plus 2 is 8. We divide that by 2, which gives us the number of pairs of electrons. Remember what we said earlier, key bits of information, we've got the B and the P. So 3 take away 4 gives us 1 lone pair of electrons. So we've got 3 bonding pairs, 1 lone pair, but the overall structure is based on the tetrahedral again. So TL is in the middle, and then we've got 3 BRs. Again, it doesn't matter which ones you draw, with a lone pair, so it's the same shape as before, trigonal pyramidal, and the bond angle is 107 degrees. Okie dokie. More complicated examples. So this is what happens when you get 5. So 5's got a lot of potential shapes. So we've got the basic trigonal pyramidal. So if there's 4 pairs of bonding electrons and 1 lone pair of electrons, it forms a trigonal pyramidal structure, which is this, and that is one of the atoms is removed. It's pyramidal because it forms a pyramid. It's not bipyramidal because there's not 2, so the top pyramid is basically gone. The bond angle's reduced to 119 and 89. Because of the lone pair of electrons, it sort of pushes everything down this way. So the bond angle here is 119 degrees and the bond angle here is 89 degrees. Okay, so if you've got 3 and 2, there are 2 possible structures. It could be trigonal planar or it could be T-shaped. To be honest, either of which are acceptable. If you drew this or this, you would get the marks in the exam unless they were steering you into a particular shape. Maybe they say it's not trigonal planar, for example. But as long as you draw the lone pairs of electrons and you get the bond angle and you name it, it's fine. So this is the T-shaped one and this is the trigonal planar. This is exactly the same trigonal planar structure as we looked at before. And the bond angle here is 120 degrees and the bond angle here is reduced slightly to 89. Now if you remember this, so why is this not gone down? Why is that still 120? So if you remember, I said earlier this is like the flat piece of paper with a bond coming up and a bond going down. I think I've just ruined this picture here, but sort of imagine like a pencil going directly in the middle of the paper here. Now if the 2 atoms above and below that piece of paper are gone and they're now lone pairs, the lone pair pushing down and the lone pair pushing up are going to be pushing equally and in opposite directions. So that means that the bond angles here stay at 120. Whereas these, because this is in a different plane, then it does mean that the bond angle is reduced slightly. And if you get rid of 3, so you've got 3 lone pairs of electrons and 2 bonding pairs, then the shape becomes linear. It's the same argument as up here. These are essentially the 2 electrons that were stuck before and your bond angle is 180. So these were the 2, that's your pencil if you want to go with that analogy. Okay, 6 pairs of electrons, octahedral, 90, 5 and 1 forms a square pyramid. Bond angle reduces to about 89, and this 89 degrees, and basically the other option is square planar. It's the same argument. The electrons are repelling here and the electrons are repelling here. they are repelling more than the bond pair repulsion, but they're repelling equally in opposite directions, so the bond angle goes back up to 90 degrees. Whereas in this example, the lone pair of electrons here is repelling more than this bond pair, so the bond angle is reduced slightly, not by as much, to 80, but to 89. Okay, so that's a summary. I will pop this in the comments section so you can get the summary of the shapes, and you literally just need to learn that, okay? And I'll correct a couple of those things that I got wrong before. So explaining shapes, okay? Now I would say learn this is just a script. Just fill in the gaps when you come to an exam, okay? Because this will get you the marks. So example, so we looked at methane earlier. Methane we know doesn't have any lone pairs of electrons. So this is what we would say. If it asked you to explain the shape of methane, you would say there are 4 bonding pairs of electrons, because we worked out there were 4 bonding pairs of electrons in methane, around the central, it's carbon, it's this one, atom. And then you say electrons repel as far as possible, and then you say bonding pairs of electrons repel equally. You don't just leave that bit blank. This bit will also explain why a bond angle is 109.5 degrees and not say 107. So do say this bit about bonding pairs of electrons repelling equally. If there are lone pairs of electrons, then we adapt what we say slightly. So for example, with the ammonia, which you remember has 1 lone pair and 3 bond pairs, we can say there are 4 pairs of electrons around the central, this time it's nitrogen atom, because there are 4 pairs in total, but 3 of them are bonding and 1 is a lone pair. We then still say the same, electrons repel as far as possible, and lone pairs repel more than bonding pairs, so the bond angle will be reduced. This bit would also explain why bond angle has 107 degrees rather than 109.5 degrees, for example. Okay, so we're going to have a look at some exam questions now. So I've picked out 3 good exam questions that will hopefully exemplify some of the things that we're looking at. Feel free to pause the video and have a go at the exam question first. Okay, so assuming you've paused it or you're just here because you want to know the answers, that's also fine. So chlorine can form molecules and ions that contain only chlorine or that contain chlorine combined with another element. Use your understanding of the electron pair repulsion theory to draw the shape of the AsCl3 molecule and the shape of the Cl3 plus ion. So we're being asked to draw the shape of this and the shape of this. Include any lone pairs of electrons that influence the shape. Okie doke, we'll do that. And then we've got to name the shape made by the atoms in the ACl3 molecule and in the Cl3 plus ion. So that's job 3 and that's job 4. So we've got 4 things we need to do for that part, and I'll come back to part B in a moment. So that's why it's 4 marks. Okay, so first of all we'll look at AsCl3. We find arsenic in the periodic table. Arsenic is in group 5, so we know that there's 5 electrons coming from arsenic. There are 3 bonds, so we do the 5 and the 3. So 5 plus 3 is 8, which I divide by 2, which gives me the number of pairs of electrons. So I now know it's based on a tetrahedral structure. However, I've only got 3 bonding pairs. So I've got 3 bonding pairs, which means I must have, that's bond pairs, so that means I must have 1 lone pair. So what's 3 bonding pairs and 1 lone pair? It's our good old friend, the old trigonal pyramidal. So AsCl, Cl, Cl. Don't forget the lone pair of electrons. If you want, you can put a little hat on it. Looks a bit like an alien. That's the orbital. You don't have to do that. The lone pair is fine. And that bond angle, which they've not asked us for, but if they did, it'd be 107 degrees. But they did ask us for the name of the shape, which is trigonal pyramidal. Okay, I'm going to scroll up now. So the next one was to do Cl3+. I'm going to change my pen colour again. So Cl3+ is chlorine bonded to two other chlorines. So the central atom is chlorine, so it's C, it's basically Cl, Cl2, if you want to think of it like that. So chlorine is in group 7, it's bonded to two other chlorines, and the charge is plus, so therefore there is one less electron. So that's the outer shell, that's the bonds, and this is the charge. So that's the bonding pairs of electrons. So that's 9 minus 1 is 8, which I divide it by 2 gives me 4. So it's our good old friend, the tetrahedral structure base again. But remember, there are 2 lone pairs because I need to do this, take away this, which gives me 2 lone pairs and 2 bond pairs. So it's our friend, the bent shape, Cl, Cl, 2 lone pairs of electrons, and the bond angle is going to be, not asked for it, but it'll be 104.5, and it's bent or V-shaped. Okay, so let's just check. Have we done 1, 2, 3, 4 things? Yes. Part B, explain why the AsCl4 plus ion has a bond angle of 109.5. So what has a bond angle of 109.5? Sorry, I don't know what's going on here. So it is the AsCl4 plus. Why it's got a bond angle of 109.5 degrees is the question. So let's work it out. So As is in group 5, there are 4 bonds, it's got a charge of +1, so that means it's going to have 8 electrons. Divide that by 2, which gives me 4 pairs of electrons. Because there are 4 pairs of electrons and 4 bonding pairs of electrons, remember that's outer shell, that's charge, that's total. So if bond pairs equals the total number of pairs, then there's no lone pairs. So we will say it's got 109.5 degrees because there are 4 bonding pairs of electrons. You can add no lone pairs if you want. And then what else do we need to say? Remember that last thing I said? Bonding pairs repel equally. Okay, so let's have a quick look at the mark scheme. So a structure for this, you've got 1 lone pair, 3 bonding pairs, that's what you're getting 1 mark for, and pyramidal or trigonal pyramidal they'll accept. 1 mark, 1 mark. This one is for the 2 chlorine atoms and the 2 lone pairs of electrons here, either dots or these little weird alien things. Bent or V-shaped or triangular. And for part B, there are 4 bonds or 4 pairs of electrons around As, and electrons repel equally, or electron pairs or bond pairs. So you're getting basically marked for repelling equally, and there are 4 bonds. If a lone pair is included in the shape, you get a chemical error, which means you can score nothing. Example, exam question 2. Again, feel free to pause it and come back when I look at the solution in a second. Okay, this question is about compounds containing fluorine. Draw the shape of the molecule of krypton difluoride, Kf2. Include in your answer any lone pairs of electrons that influence the shape. So we've got to draw the shape, name the shape, produced, and suggest a bond angle. So there are 3 things to do there. So same thing again, krypton, F2. So krypton, we find that in the periodic table, and we'll see it's in group 0. That means that there are 8 electrons in its outer shell. There are two bonds because it's F2. The charge is 0. So I'm going to do, to get the pairs, 8 plus 2, which is 10, divided by 2 gives me 5. So there are 5 pairs of electrons, and there are 2 bonding pairs, which means there are 3 lone pairs. So if you remember back to that table earlier where there are 5 electrons, if 3 of them are lone pairs and 2 of them are bond pairs, that gives us a linear shape. So krypton with the 2 fluorines, and then we need 3 lone pairs of electrons. The shape is linear and the bond angle is approximately 180. So that's the shape, that's the name, that's the bond angle. Part B, there are 2, I'm going to move this up, zoom in and out and do all sorts of stuff as well. There are 2 lone pairs of electrons on the oxygen atom in a molecule of oxygen difluoride, OF2. So we're told there's 2 lone pairs. Explain how the lone pairs of electrons on the oxygen atom influence the bond angle in oxygen difluoride. So we know lone pairs repel more than bonding pairs. So the bond angle will be reduced. So explain, we give a reason why. It's 2 marks. We've done that. Let's have a look at the mark scheme. So we've got the shape, any shape, any diagram with 2 bonds and 3 lone pairs they'll accept. Linear, they will not accept anything else than linear, that's why it's underlined. 180 degrees, they will not accept any other answer than 180, that's why it's underlined. Lone pairs repel more than bond pairs, allow the idea of a reducing bond angle, so the bond angle will be lower. You could quote between 103 and 106 to get that mark as well. Okay, last question we'll look at. Again, if you want to pause and have a go and then come back, do that. So chlorine is a period 3 element. Thank you. Chlorine forms the molecules ClF3 and CCl2. Use your understanding of electron pair repulsion to draw the shape of the ClF3 and the shape of the CCl2. Include any lone pairs that may influence the shape. So we're going to go do the same that we did before. So we'll do ClF3. So chlorine is in group 7. So it's got 7 electrons. They're not told us the group there, they're told us the period. There are 3 bonds basically, and there is no charge. So 7 plus 3 is 10. Divided by 2 gives us 5. So there are 5 pairs of electrons, 3 bonding pairs, which we said here, and 2 lone pairs because 5 take away 3 is 2. So it's going to be based around the T-shaped or possibly the trigonal planar molecule. Either or would be fine. So we're going to have chlorine with a lone pair of electrons there and another lone pair of electrons, and then we're going to have 3 fluorines around it. The bond angle would be about 89 degrees. That one would be T-shaped, or if you wanted you could do the trigonal planar with the 2 lone pairs as well. But we've not been asked for the name, we've just been asked to draw and lone pairs. So as long as we've got 3 bonds and 2 lone pairs of electrons, it doesn't really matter. And then we need the CCl2. So the central atom, so the outer shell electrons, is carbon, which is in group 4. There are 2 bonds, which gives us, and there's no charge, which gives us a total of 6. Divide that by 2, which gives us 3 pairs around the central atom, 2 of which are bonding pairs, which means 1 of which is a lone pair. So you've got 1 lone pair and 2 bond pairs. So the shape is going to be based on the trigonal planar, except it's got a lone pair of electrons. So it's not called trigonal planar anymore, it's called bent or V-shaped. There's your lone pair of electrons. Not asked for it, but if they did, the bond angle would be about 118. So So again, we'll look at the mark scheme. So something like that, 2 lone pairs of electrons with the 3 fluorines, any structure with 3 bonds and 2 lone pairs. For this one, again the lone pair there and the 2 chlorine atoms here, and the name of the shape is bent or V-shaped. So that brings us to the end of the video, shapes of molecules. So we've looked at hopefully working out the number of pairs of electrons around the central atom, deducing the shape of the molecule, the bond angle and the names of shapes, and explaining why a shape has a particular bond angle. I really hope that was helpful. Thank you very much for listening. Bye bye.